Measures of center and proportion. The mode, median, mid-range, and mean are known as measures of center or central tendency or location. Consider these 5 birth weights in ounces ranked from smallest to largest. So we have 59 ounces, that's the smallest one, 93 ounces, that's the next smallest, 102 ounces, 111, 120 ounces, that's the biggest one. Find the mode. So the measures of central tendency, mode, median, mid-range, and mean. So the mode is the most frequently occurring birth weight. There can be more than one mode. If each data value occurs exactly once, then there is no mode. So the answer here would be no mode. Okay. The median is the middle number when you range them from smallest to largest, or if it could be the average of the 2 middle numbers when you rank the scores from smallest to largest. It's the same as the 50th percentile or the second quartile. Here we have an odd number of scores. We're going to only have one score in the middle. That's going to be the 102 is going to be the median. Okay. So it's 102 ounces. If scores are not already in order from smallest to largest, then before you find the median, you have to arrange them from smallest to largest. The mid-range is going to be the average of the smallest and the largest numbers. So it's the min plus the max divided by 2. So in this case, the smallest birth weight is 59 ounces. 59 plus, and the biggest one is 120, and divide by 2. So 59 plus 120 is 179, divide by 2, and that's going to be 89.5 ounces. Okay. And then the mean so mean is basically the total of the scores divided by the total number of scores. Sometimes it'll be useful to have a notation here. The Greek letter uppercase sigma looks like this number here. That means sum. The notation, if you have a k equal 1 at the bottom and n on the top, that means the sum as k goes from 1 to n. So it looks like k equals 1 and then an n on the top, but the way you read it as the sum as k goes from 1 to n. So the mean, it's the sum of the scores divided by the total number of scores. So it's the sum as, and it's represented, the sample mean is represented by x with a bar on top. It would be that x bar. So it's the sum as k goes from 1 to n of xk, the whole thing divided by n. In this case, we have 5 scores, so n is going to be 5. So it'll be the sum as k goes from 1 to 5 of xk over 5. So it's the first score, x1 is the first score, plus x2, plus x3, plus x4, plus x5, and divided by 5. And the order actually doesn't matter. I'll use the order we had, the smallest to largest order, but for the mean, you can put them in any order you want. So x1, the first score is 59. Plus x2 would be 93, the second score. Third score is 102, 111 plus 120 divided by 5. Okay, so we want to add those up and divide by 5. Okay, so okay, so 9 and 3 is 12. 2 is 14 and 1 is 15. Actually, okay. Carry the 1. Let me add these again. I'm a little distracted here. 5 and 9 is 14, 15. Looking at the last digit. 9 and 3 is 12. Plus 2 is 14, 15. So put down the 5, carry the 1. 1 and 5 is 6, and 9 is 15, and 10 is 25, 11 is 36, 48, 485 divided by 5, and so 5 into 485, and 9 times 5 is 45, remainder 3, bring out 5, 5 and 35 goes 7 times. So the mean is 97 ounces. Okay, so those are the four measures of center: mode, median, mid-range, and mean. We could also talk about the proportion of scores. If we look at the proportion of scores, proportion of birth weights that are over 100, well, it's 3 out of 5 were over 100. So the 102, 111, and 120 are all more than 100. So that's three birth weights out of 5 over 100. So as a fraction, the proportion of birth weights over 100 would be 3/5. And then for some purposes, we might want to convert to a decimal, and then we divide. 5 into 3 goes 0 times. At a decimal point at 0, 5 into 30 goes 6 times. 6 times 5 is 30, remainder is 0. So it would be 0.6 as a decimal. And then if we make it into a percent, we'll get 0.6 times 100. To make it into a percent, it would be 60%. So it's 60 as a percent. Proportion as a percent. As a percent. Okay, so that concludes this presentation.